U-sub or no U-sub? Hi everyone. For some reason, I'm struggling with the idea of U-substitution and want this some clarity. Okay, let's take a look. We are going to integrate x squared plus 1 over x to the third power plus 3x. So here's the typical thing that we can try to do. Starting with a selection for the u. Sometimes it's the inside of the parentheses, sometimes it's the denominator, sometimes it's in the exponents. We don't know yet. In this case here, let's try the u to be the denominator. So x to the third power plus 3x. Now, the next step is we'll differentiate this. If you differentiate this with respect to x, on the left-hand side is technically du over dx. And then just do the usual derivative. Use the power rule, bring the 3 to the front, and then minus 1. We get 3x squared. And then the derivative of this is just 3. And then you can just go ahead and multiply the dx to both sides. You get du being 3x squared plus 3, and then multiply with dx. And because you do this all the time, so you could have skipped this step. You can just go from here to here if you would like. Now, this right here will be really helpful. This is how I teach my students. When you look at an integral, pay close attention to the d whatever. Here we have dx, so we call this the x world. In integrals, x world is not always going to be so nice because I cannot recognize the derivative function will give us this right away. So we'll be going to the u world. And this is how you do it. Still have the integral. On the top, we have x squared plus 1 over, right here we have our u. Good. Put it down here. And then notice that we still have the dx here, right? Okay, what's dx though? We have this equation, du is equal to that. We have the dx here. So we are going to divide this to both sides so we can get the dx by itself. Now, putting down the dx first, we will have du on the top over this right here. 3x squared plus 3. And we can put that right here. Du over 3x squared plus 3. Now, we are in the u world, but there's one condition. In the u world, x is not allowed. We have the x squared plus 1 and then this right here. So what do? Well, sometimes we can actually cancel them. In this case here, have a look. 3 and 3, we can factor out the 3. So this right here is the integral x squared plus 1 over u times du over factoring out the 3, we get x squared plus 1. X squared plus 1, x squared plus 1, they can cancel. In the u world, it's much better. Sometimes you may have to go back to the equation for x and the u, and then you may have to solve for x in terms of u. That will be a topic for another video. In this case here, we see that we have 1 over 3. It's a constant multiple. Put it on the outside of the integral, and the integral, we have 1 over u, and then du. Now, in the u world, remember this. It's either that you have to think about the derivative what function will give you this, or you will use the reverse power rule. Do we recognize the derivative what function will give us 1 over u? Well, the answer for that is ln of u. So we get 1/3 ln of u. Technically, with an absolute value, right? And then right here, some people may want you to put down a plus c right away. I will do that for you guys here, but usually I just put down a plus c at the very end. Not done yet though, because we still have to go back to the x world. U is that. So we get 1/3 ln absolute value x to the third power plus 3x absolute value and then plus 3. This function inside here could be negative, so you have to maintain the absolute value. Alright? So that will do it. And if you want to see more examples on the U-substitution or integrals in general, definitely check out my playlist. I have tons of tutorials for you guys right over here. Hope this helps. That's it.